Okay, so that was question 14 of math paper 1 2016. All right. Okay, so I hope you can follow it like that and look at that question. Okay, that's the question we'll be answering now. All right, so question 14, part A. Okay, so part A is, we're given that universal set. Okay, the question is find A union B complement. Okay, so given the universal set E, okay, there's A, B, C, D, E, F, G up to H. Okay, yeah, then we're given A as A, B, C, D. Okay, then we're given B as B, C, D, E, F. Okay, and then the question is find A union B complement. Okay, so what they're simply saying, what this means is find the elements that are not in A and B. Okay, so when you look at A, it has A, B, C, D, right? So you can go to the universal, cancel A, B, C, D. Okay, then you come to B. B has B, C, D, E, F. So you can see B is cancelled, C is cancelled, D is cancelled. So the other elements remaining are E and F. Okay, so you remove E, you remove F. What remains in the universal set is G and H. Okay, so when you look at the original elements in A and elements in B, you'll find that the only elements that are not in these two sets is G and F. Okay, therefore you answer your question because you're finding elements that are not in A and B, which is G and F. So that is your answer. Okay, all right, so we'll move to part B. Part B, you're told to say find the equation of the straight line passing through. So this straight line is passing through these coordinates -4, 4. Okay, and this same line that is passing through these coordinates is perpendicular to the straight line whose equation is y plus x over 7 is equal to 1. Okay, so a line that passes through this is perpendicular to this, so you can assume that that line that's passing through -4 and 4 is this line. Okay, so for it to be perpendicular, that means when they meet, they make a right angle triangle. Okay, so you can assume that this is the line that passes through -4 and 4, and then this equation we're given is this line. Okay, it's this line. All right, okay, so now they want you to find the equation of this line that is passing through these coordinates. Okay, all right, so to find that, remember 1 point form, one point equation. Okay, 1 point equation, the formula is y minus y1 is equal to m open bracket x minus x1 close, right? So this is the equation. If you want, this is the formula if you want to find an equation that passes through 1 point. Okay, so this is your x1, this is your y1. All right, okay, so when you look at this equation, we have y1, which is this one, we have x1, which is that one. Okay, the only thing missing for us to find this equation is m, which is the gradient, right? So you have this other line, okay, that has, we're given the equation of. Okay, so let's find the gradient of this line. Okay, so remember we'll use the y-intercept. Y is equal to mx plus c. So when we express this equation in this form, we'll be able to find the gradient of this line. Okay, so that is y plus x over 7 is equal to 1. Okay, let's express it in this form. let's make y the subject of the formula. All right, so to make y the subject of the formula, we have to get rid of this, right? So this is positive x over 7. So to get rid of this positive x over 7, we just subtract it with x over 7. So what you do the other side, you do the other side. So minus x over 7. So this and this goes. You remain with y is equal to 1 minus x over 7. Okay, so you know that here the coefficient of x here is 1 over 7x. This and this are just the same thing. Okay, then you bring your intercept formula, which is y is equal to mx plus c. Okay, so you see that c is represented by this one, y is y, then this mx is this. Okay, so as you can see, the coefficient of x here is negative 7 over 1. The coefficient of x here is m. Okay, that means the gradient is negative 1 over 7. Okay, all right, so we found the gradient of this line. Okay, now what would be the gradient of the line that is perpendicular to this? Okay, I'm sure you were taught that for two lines that are perpendicular, when you multiply their gradients, that is one line by the gradient of one line by the gradient of the other line, if they are perpendicular, should give you negative 1. Okay, yeah, so we have the gradient of one line, which is negative 1 over 7. Then if you multiply it by the gradient of the other line, should give you negative 1 if they are perpendicular lines. Okay, all right, so you have seen there's this fraction here, negative 1 over 7. So to get rid of this, because we want to remain with m, we'll multiply it by negative 7 over 1. Okay, so even the other side, negative 7 over 1. So this goes with that, that goes with that, so you only remain with m2. Okay, so here negative 1 by negative 7 over 1, that is just positive 7 over 1. So gradient of 2 is 7. Okay, all right, so now when you look at this, excuse me, now when you look at this, we have the gradient of this line that is perpendicular to this one. Okay, so now we can go back to our 1-point formula. Okay, which is y minus y1 is equal to mx minus x1. Okay, remember the points are negative 1, 4, and the gradient we found it to be 7. Okay, so we can just replace now. So y minus, remember this is x1, this is y1. So y1 is 4, m is a gradient which is 7, and then x minus x1. x1 is negative 4. So don't make a mistake of thinking this negative is that negative there. Okay, they are two separate. This negative is in the formula. This negative is moving with this point. Okay, all right, so y minus 4 should give you 7x. Then this negative by that negative gives you positive 4. Okay, so y minus 4, this by that, that is 7x. 7 by 4, that is 28. And then we'll want to remain with y. Okay, so minus 4, we have to get rid of this, so you add plus 4. What you do this side, you do the other side, so you even add plus 4 this side. So this 4 goes with that 4, you remain with y. So you have 7x plus 28 plus 4, that is 32. Okay, so this is your equation. All right, thank you.